Hello everyone, I am Fernando Daniel, creator of this Metaleptic self-portrait built entirely with GLSL Shaders. In this video, I'll take you on a quick 3-minute tour of the core ideas behind the program. I rely on GLPW, GLAD, STB image, and, of course, OpenGL in C++. I won't dive into every mathematical detail, there's simply no time, but I will cover the essentials. OpenGL turns your vertex data into pixels via a sequence called the graphics pipeline. To keep things simple, we'll focus on two stages, vertex shader and fragment shader. The vertex shader handles position. I draw two triangles that form one full screen quad, so the fragment shader runs for every pixel. Fragment shader calculates each pixel's color in parallel on the GPU. Every fragment carries all the logic it needs to render itself. My self-portrait uses 3 shader layers stacked on that full-screen quad. Background, a rotating spiral of 16 rings that change color over time. The fog layer, a colorful animated cloud effect driven by procedural noise. And the top texture, a vector art version of my face with transparent regions revealing the layers beneath and a pseudo Gaussian blur for softness. First, in the background spiral shader, we read the pixel coordinate and convert it to a centered aspect-correct position. Expose and depose let us shift the spiral center on the fly. The loop builds 16 concentric rings. A time function gets the polar angle. Then we animate it with time and offset by I. Mod function wraps the angle, minus p recenters it, and multiplying by length preserves the radial distance. Finally, we color with cosine pattern and soften with tan. In the animated cloud shader, first we build a 3D coordinate where theta is equal time, so the noise evolves. UV distorts UVs, and the gradient radial fades the fog from the center to edge. I map the parameter U color param into an RGB tint using sine waves, giving a smooth shifting hue to the fog. Note that I am hypersimplifying here. The full 3D simplex noise algorithm comes from Ashima Arts under MIT license. I use a compact version for a real-time performance. The vector art shader works with alpha channel textures. It applies a soft localized blur only where the image is partially transparent, creating a smooth blend with the layers underneath. First, we compute each neighbor's contribution with exponential falloff, simulating a Gaussian kernel. Pixels farther from the center contribute less, smoothing edges, without destroying detail. The opaque areas, where alpha is equal 1, stay crisp. The semi-transparent edges blend more with the blur, creating a soft halo. And finally, the almost invisible pixels still leaves a faint glow, enhancing the atmospheric effect. Thank you for watching.